we go. Sorry about that. Um, so the second part I put in was a pulley, and just mainly just to see your familiarity with pulleys. Now you'll be seeing a lot of pulleys in dynamics if you have to take dynamics, so it's good to get familiar with them. They're not really complicated as long as you follow a certain protocol or steps with them. So, for example, in the quiz, I was just asking you to determine the tension at one, given that you had 100 kilograms hanging, and most of you got that. You saw that if you cut the cable, and that's what you do with a pulley is you cut it, and so you have the 100 kilograms hanging, and you have two tensions pulling up, and each of those has to equal 50 so that you have equilibrium, and then that 50 goes to the middle pulley, and so the middle pulley then is broken up into 25, and then that 25 just goes around the top pulley and down to one, and so you end up with 25 kilograms times gravity. It gives you your value for the force. So I did, I put pulleys on the last midterm in winter. I think so, maybe it was fall, but I did, and I think they might have been a little too difficult. So um, as far as the way I grade, I've probably brought this up before, but I try to give you challenging problems on the exam, but nothing that you can't do. But if I do make a mistake and they're too difficult, then I always curve it. So, but that said, I've done this enough that I have a pretty good idea what you guys should be able to do. But every so often I overshoot a little bit. Okay, so the test. So the midterm format, you'll have 3 to 4 questions. Not sure which number. Have a few problems written out, sketched out what I want to do, but not finalized. They're increasing difficulty. So usually the first question is meant to be, maybe out of 100 points, it's maybe 15 points, and it's meant to be something fairly simple, something you've done before, take only a few minutes to answer. And then it goes up from there. They'll be similar to homework in the sense is that you'll have a problem that you'll be asked maybe just a specific thing and you'll have to solve for it. But it'll model the homework problems, and then and the only difference is on the test because of time. I might either give you things like unit vectors, like I did on the first quiz, or I might give you um, or not make you solve everything. I might just have you set it up. So it just depends. I try to make it reasonable in terms of the amount of time that you're doing. And so I opted to do this asynchronous format because I know there's a lot of stress on the test, and otherwise it would have been a 50-minute exam from either 8:10 to 9 or 9:10 to 10. Because if I do a live, I can't do it any longer than that because I don't know your schedules otherwise. That's the only time I have allotted. So I opted for the asynchronous format, which has its pluses and minuses, but I think overall, I think it'll be easier for you guys. It'll give you a little more time to do the problems, and the stress won't be as great. And my hope is that overall, you'll do better on it. So be sure you read the problem. I know that sounds simple. Like, of course, I'm going to read the problem, but it's amazing after all these times I've taught statics, the problem I think what happens is you're anxious, you want to get the test done, the stress level's high, and you don't read everything, and then you end up either not answering the question I asked or you answer too much and waste time on it. For example, on a previous exam, I gave an option. So I gave 2 problems, you could pick one, and I had at least 3 people do both. And then I only counted one of them, and then that left them with less time for the last problem. So it kind of came back to bite them. So don't do that. Make sure you show your work. Very important that you show your work, and free body diagrams. And I'll say that the homework, I will, as I said, I'll have the homeworks graded by later today or tomorrow. But one of the things I am noticing is that some of the diagrams are not what they should be. So it's really important. homework 4 and beyond, and especially on the exam, is when you're drawing a free body diagram, it's very important that it's detailed, it's neat, it's something that's legible, and it's complete. So I will grade that part of the part of the test grade on the or part of the problem grade will be on how well do you draw the free body diagram. And you may have noticed on previous tests, I may just give you a free body diagram and just ask you to draw that. That's the whole question, is just how well you can draw it. And it might seem simple, but surprisingly a lot, if I give you something where I tell you it's a thrust bearing and I explain what it is, people will miss it. And it's mainly because not reading the question. So just don't take anything for granted. I'm not trying to trick you on these tests, but I am trying to make sure that you understand the material. So any questions on this so far? The last thing I'll say is that because of the asynchronous format, I will be available via email most of the day, but if you may not be able to have a real-time answer, I would say state your assumption and move on. So if you're not sure about something, make a reasonable assumption and I'll look at that. So sometimes the question, you might not read it the same as how I intended it. And so if you say I'm going to solve it this way and you do, and it's reasonable, it has to be reasonable, then I may accept that. All right. So that's the format. So let's talk about the material. So I typically don't ask specific questions from chapter 2 because chapter 2 is more or less a review of what you guys have, or not a review, but you're learning things that you're going to be applying to future chapters. So there's no specific questions. You had a few kind of 3D equilibrium at the end with the objects hanging from the ceiling, but those are really no different than problems in chapter 4. So as far as the main topics of chapter 3, you have a moment about a point or a line. And I'll say this again, and it may seem like I harp a lot, but remember, a moment about a line is a vector, and R is never a unit vector, and it always goes to the force. And inevitably, I see mistakes where whoever's doing it doesn't do that, and don't make that simple mistake. It's like giving away points. So if you have to write it on a note and staple it to your forehead, so be it. So the other thing is, when you're doing moment about a line, remember that the lambda is the unit vector of the line itself. M ends up being a scalar, not a vector. And R cross F, again, is going to any point from the line to any point on the force. All right. Now someone asked last hour, can you make M a vector? Well, you can. If you get this answer, after you get this answer, you get a scalar magnitude, but you could take that moment scalar and you could multiply it by the unit vector of the line, and then that would give you the actual moment in a vector form about the line. And it's related to how, when we talked about force, those early homework problems where you're projecting force on different lines. I don't anticipate asking you a question like that, but it's not really a difficult idea. It's just you're taking a scalar and you're multiplying it by a unit vector to get a moment. I'm sorry, to get a vector. Okay, force couple systems. So force couple systems, moving a force to a different location. You just remember that the answer always includes the force. So whenever you move the force to the new location, your force stays the same, whatever it was originally. And then you do R cross F, where R is the point from the new location to the old location. And then your answer is just the moment and the force. And that's it. And then you have equivalent couples, because if you add the forces, and if all you have are couples, then the sum of all forces are 0 because they cancel each other out. So I could give you, one question with 30 couples, and that would be it. Actually, that'd be a good final question. I could give you just one problem on the final, and it'd have 30 couples, and it'd be all wrong or all right. So you either get an A or an F, and that'd be the only way I'd grade the class. That's kind of how they do it in Europe. They have in I've heard that in Germany they have only only finals. There's nothing during the quarter that they turn in. So your whole grade on the class is based on your final exam at the end of the quarter. Sounds pretty sketchy. Sounds pretty hairy. So anyway, that's equivalent couples. And then last we talked about equivalent systems. So replacing multiple forces with a single force, and that's just in 2D. We didn't go into 3D on that. So, but those were all represented in the homeworks, and so it could be maybe one type of those problems or two, but those are the main ways that we broke down chapter 3. And then chapter 4, you just had 2D or 3D equilibrium. So you had free body diagrams. You always have a free body diagram, and then in 2D you had 3 equations summing the forces in the x and the y in a moment about a single point. And then 3D was very similar. You do r cross f, multiple r cross f's, set them equal to 0, solve, and then you'd go back and solve for your unknown reactions. Now I did create this. Let me show you on this midterm study guide. Looks a lot like this, and it's on Canvas. If you go to the I'll just show you in a second. It's the Canvas page with all the solutions. But so what I did with this is this is something I would let students use during the exam, and then I'd have a little area for a page of notes or something if they want to put stuff in. But this basically goes over mainly chapter 3, the different methods of how do you do things. So it talks about first vector products, and then it talks about moment about a point, moment about line, couple, force couple equivalent, and then it goes into chapter 4, equilibrium rigid bodies. So if you look at where's Canvas ID? Oh, sorry. If you look here under assignment, quiz, exam solutions, then midterm study guide. So I posted that, and so I would take a look at it. I find I tried to make it a resource so that you would have a way if you got stuck on a problem, you could see the method of it. Unlike dynamics, a lot of the statics problems are fairly repetitive in terms of the way they're done. Dynamics tends to be a little more variety, and so I think that's why it's more challenging, because a lot of the problems are, they can be grouped in like groups, but the way you solve them, it seems to be a multitude of different ways, whereas I think statics is just kind of plug and chug in a lot of these. Anyway, so here are the other exams too. If you haven't had a chance to look them over, I would take a look just to give you an idea of the depth of the questions that I'll be asking. And I did post the solutions to the 3 quizzes and the 3 homeworks. All right. So that's all I have. So what questions do you
have? Is the majority of the midterm exam going to be on content from chapter 3, or what would be a kind of an even split?
Probably an even split. Usually, probably 3 and 4. I tend to, if you look at my past exams, usually the hard problem, the last problem, is usually a 3D equilibrium from chapter 4. So, I try not to make, my tests aren't really a mystery. I think if you look at each of the exams, you kind of see a pattern to them. They have combinations of chapter 3 and chapter 4, but usually the difficult problem is some type of a 3D equilibrium problem. So if you understand that, you should be fine. What else?
This is a question from the homework. I was kind of wondering
Uh-huh.
if you asked for like a force or a tension, but you don't say like the magnitude of the force, would you want components or just the magnitude? There's like one
Oh,
question where I wasn't sure about that.
usually if it's a force, then it's usually in vector form. If usually you'll end up with a force in vector form. The only time is if you do a moment about a line, then it's a scalar, and I don't expect you to convert that to a vector by. So yeah, I would say just put it in its IJK components. Don't worry about finding its magnitude, because as long as you have it in the IJK, that's fine.
If it's like a tension where we're just solve for the magnitude, would that be okay?
Yeah, in that case it would. So if you have, because I know what you're saying, if you have like if you have a pole and you have like two tension wires that are holding it, it says find tension AD and AB, then you're right. That's just asking in that type of problem, you're just specifically asking for the scalar. And so usually it'll be in the problem itself, it'll say it, and unless I write it bold, bold means vector, or I'll say the vector TAB, or if it's a italics, it's a scalar. So hopefully it'll be clear. But yeah, it's because if it just depends, I guess it just depends on the context of the problem, because a lot of times if you're finding the tensions in cables and they're unknown, you know the vector directions of them because you know the unit vector for those. And so, but you use that unit vector in order to break them up into IJKs, and that's how you're able to actually solve for those scalar values. But once you get the scalar values, you don't have to revert them back to a vector unless I specifically say that.
Thanks.
Sure.
I've got a question about that too. For moments in 2D, do you want us to just describe them as either clockwise or counterclockwise, or should we put in a 3D vector?
In 2D? Oh,
Yeah,
you don't have to say K. I mean, they're by default, they're about the K direction, right? Because we assume Z is coming out of the page. No, if it's a 2D moment, then you can either write the value and then write CW or CCW, or you can write negative or positive to represent the direction. Either one's fine.
okay. How do I clarify like negative or positive for the direction?
So counterclockwise is positive. That's our convention, and clockwise is negative.
Okay, thank you.
Sure. What other deep questions do you have?
When there's different types of joints for the midterm, will there always be clear like exactly how the joints work, or will there be some like vocab we need to memorize from like one of your lecture videos when you were going over the joints?
Oh yeah, the reaction types. No, I don't generally want you to memorize reaction types. You'll have, obviously you have your notes in your book. The reaction types. There is a document that I provide on the final, but I'll also provide it on the midterm. So it'll be with the midterm. I'll try to post it sooner than that so you can see it. But it's the it's out of a different text, which I think it actually is more comprehensive than the one that you have in your own text. But generally, the types of reactions that you'll have, I'll either spell them out for you, or they should be fairly obvious, because I don't want you to not understand it because you don't know the reaction. So a lot of times the 3D equilibriums will be like a ball in a socket, or there'll be some kind of a thrust bearing or a journal bearing. And so I do talk about in my lecture about like whether certain bearings can support a load in their axial direction. So that's something that you'll want to understand that. So what I mean by that is, let me put on my doc cam. What I mean by that is sometimes you'll have, like, say you have so here's a shaft, and then you'll have, I guess I should have drawn. So there's that, and then you know, something like like that, and it'll be a bearing. So typically bearings like this, if you think of, and I explained this in my lecture, but if you think of like ball bearings, you know, ball bearings are, you know, they look like this. You have, you know, you can have needle bearings or ball, but they're all similar in the senses that they're very good in forces in these directions, but they really don't have any lateral strength. They're not designed to support loads in that. That'll destroy them. So if you think about something spinning on a journal, usually the reaction would be this and this, but nothing this. But I don't expect you to just to know that, because from a drawing you can't. So sometimes what you'll see is it'll say, like, say this is A and this is B. And the wording might say A cannot support an axial load. Now, it doesn't say anything about B, but if it says something A does, that means that there's no force along the line of the bearing. But B, it doesn't. So then you assume that and that there's that reaction there. I usually try to spell it out even clearer than that. Like I'll name one a thrust bearing, one a, and I'll say, and if you look at my examples of my exams, you'll see that I actually write it out. And that's why I was mentioning it's very, very important to read the problem, because I'll be specific. And part of it is like looking at that and following what I say. But if you have something like this, then of course you want to account for that reaction. Now it might turn out that that reaction is zero if these are the only forces acting, because there's, you know, this, in this case, that this was the Y direction, and you sum the forces in the Y, and all you have is By equals zero, then that's it. But nonetheless, you want to identify it, even if it is zero on the free body diagram, unless it specifically says something like this, or some wording where it tells you there is nothing like that.
Okay, that makes sense. Thank
All
you.
right, sure. What else? You guys must have some questions. All right, we'll play Hangman, right? So I could just call on random names, and you have to give me a letter. Or I could go ahead.
I am stuck on one of the homework problems, but I guess this might not be the right place to discuss.
No, that's
it.
all right. Well, if no one else is asking, you may as well. What is it?
Okay, it's the last problem.
Is this on homework 4, I assume?
Yeah, it's the
All right.
last problem, and I'm a bit stuck because it appears to me that there's 7 unknowns when I can only have 6 equations.
That's
but
right. So how would you deal with that?
Well, you need 7 equations.
Yeah, but how do you get rid of 6 of those unknowns?
I'm not sure.
So
Well, you need 6 equations to get rid of 6 unknowns.
that is true. The other thing you could do is you could draw a line between A and E. So if you think about it, you have something that looks like this, and then it comes up like that, and it goes across like that, right?
Yeah.
And you're right. And you're right. You have the 6 unknowns there. And then you have this going up like this, and then you have that coming down like that. So if you connect a line from here to here.
And the moment going around it is 0.
Yeah, exactly. So you just
you
take a moment about AB. And so you know that that's just going to be, it's going to be essentially lambda AB dotted with R cross the negative 640 J, and then plus lambda AB dotted with R cross, and then that would be tension DF. Sorry, it's getting kind of messy. Tension DF, and then all that equals 0.
Oh, wow. Okay.
Yeah.
Thank you. That makes a lot more sense.
Yeah. So I know I agree. It would be very painful to try to solve all those. I don't think you could. I haven't actually tried it, but maybe one night when I'm, curled up by the fire, I'll try it. But I wouldn't.
Oh,
I
like
wouldn't
to
hold
solve for each reaction?
Yeah, I don't think you could with the information you have.
Yeah, I tried. It's a 6x6.
Yeah.
And I just made one assumption that Fe or FeZ would equal to the tension Z, but that is basically just the moment. So yeah, it's 6 equations, 7 unknowns. You can't really do it.
Yeah.
Cool.
Now
Well,
you
thank
can.
you.
Sure, no problem. What else? Well, if you don't, I won't torture you. If you don't have any questions, that's okay. I do have office hours after this from 10 to 12, and then I have office hours tomorrow, 1 to 3. So I'll be available. I apologize for last week. I had to be in Los Angeles on Tuesday, and then it went over to an extra day, unfortunately. So hopefully everyone got taken care of in office hours that I made up for on Thursday. But I'll be here later today and tomorrow if you have questions. If anything new comes up regarding the test, I'll definitely send out an announcement. But otherwise, I would just plan on, sometime between 8 and 4 on Wednesday, taking the test. Okay. Okay, you guys, if there's
Professor,
nothing
is there a
else-
certain time
sure.
limit between 8 to 4? Like once we start taking it?
Well, yeah, the test will be, the test time limit will be about between 60 and 70 minutes. I haven't decided yet. So, and that'll include that'll be total time to get it uploaded. Yeah. So there is a ending time. And so the thing is if it does end at 4, then you don't want to start taking it at 3:30, because then you only have a half hour to take the test. So you want to make sure you have enough time to have the full amount of time that you need.
Okay, I see.
All right.
Thank you.
Sure. Anything else? Any last minute questions? Okay. Well, come see me in office hours then if you have any questions. Otherwise, good luck on Wednesday, and I'm sure you guys will do fine. Thank you, guys. Thanks for coming.
Thank you.
Thank you.
Thank you.
All right. Have a good day.
Professor, I also have a question. Are you
Sure.
gonna have our quiz 3s? Sorry, I'm kind of sick, but are you gonna have our quiz 3s up before Wednesday?
Yeah, I will. I'm about a third way grading them. I'm hoping to have everything graded by the end of today.
Okay, and I know our quiz, my quiz 2 is in, but can you make it like open so I can see the question again?
I think you should be able to. Can you not go in and look at it?
It says like the answers aren't revealed, but my grade shows.
So what does it show? The grade, but does the actual quiz itself? Can you see the quiz?
Last time I checked last night, no, it didn't show.
Really? Because I left it open. That's weird. That's really strange that you should
try to pull it up real quick.
Yeah, I mean, because sometimes it does stuff for me because that it may not do for you. So if it doesn't, I'll get that open because it should let you. It should let you look at it. It just won't let you take it again.
Yeah,
So what
quiz 2, it says correct answers are hidden.
Oh. Well, I have the solutions posted for that.
Yeah,
Can
but
you-
I just want to be able to look at the whole question again.
But you can't see the question either. Then
No.
is what you're saying.
Yeah.
Ah, all
Yeah.
right. Okay, I'll see what I can do about fixing that. Okay.
Because I couldn't remember, like I did pretty good on quiz 2, but I never had a question where it was like you take it was like a moment about like I can't remember, like was it 2 lines?
I was one line with 2 forces.
1 line, 2 forces. So I was pretty close to the right answer, but I didn't know how to multiply like the lambda by individually both
Yeah.
and then add them. Well,
What?
yeah,
Yeah.
and
Or you could do. I mean, you could add the moments and then lambda all of both of them added, or you could lambda them each separately. Either way worked. But yeah, you had to
so
add.
yeah, for me on my quiz, I see where I messed up, but I added the forces
Uh-huh.
and then I multiplied them by lambda. But I didn't do it in a matrixy form. I think I just added them and then multiplied. Here, let me try to pull it.
Let me pull up your quiz right now while I have you. Grades. Let me just get that here. Just give me a second. Where'd you go?
But I definitely didn't get the right answer because in the beginning, for finding the lambda, I forgot to square root the bottom. So, but everything after that was just fine. I did like all the process correct. Just I forgot to do square root 68.
Oh, U68. Yeah. I think I see. Where'd it go? Oh, yeah, here it is. These 2. All right, let's go ahead and look at it. So,
And I took. Is it okay that I did the R from the C instead of? I think you did it for.
I did it from E, but you can
Yeah.
do C. Yeah, that's fine. Yeah, you
E
went.
would have been easier. I see that now, but
Yeah,
Yeah.
but no, that's fine to go. I think you got the 320, the 240, the 300, so that looked good. You got the 464, then 125, the 240, 320, 240, 320, and 400. So land EC of those 2 scalars. What happened there? I mean, you should be able to lambda EC both of them together. I'm not sure why. There must be a math error in there
it was
because
because of the rad 68.
oh, that's right. That's right. Yeah. But I mean, otherwise, yeah, it looks good. It looks good. Actually, yeah, actually, I should have given you, let me change that. I should have given you 24 on that.
Yeah, no,
So
I was kind of wondering because I know someone else that did like I thought I did it like really right, and I know someone else that did it like pretty wrong, and they also got a 21, and I was like, what?
Yeah, no, you should have got 24. I just changed it to a 24.
Okay, thank you.
Yeah. So, but otherwise, you understand. Yeah, the main thing is you understand it. But I'm surprised that you can't see it. That's really strange because I thought I set that up that way so that you guys could actually see the quiz. Because the answer is 300. The answer is between I made it between 58 and 63.3 because I give a range and people round. And then that way, and then I always, and if someone's outside that, I always go and I could, because even if they get it correct, I usually go through and I grade it.
I'm actually on my phone right now, and like this is what it looks like. It says the quiz.
Oh, okay, I see that. All right, let me play with it and see if I can't get that to open up for you guys.
Okay.
All right.
And yeah, that was the only question I really had.
Okay.
So it goes up to like the first lecture of this week, the midterm.
Yeah. Basically, it's all of chapter 3 and chapter 4.
Okay.
Okay.
Yeah, and so it's gonna be like 4 questions, but only 70 minutes. Is it gonna be like one question that's like kind of connected, because I can't really imagine myself doing like 4 of
Well,
these quiz questions in 7
No, it
minutes.
wouldn't be. They wouldn't be that way. They'd be. It might be 3 questions. It'd be something. If you look at my old tests, have you had a chance to look at them? Because you'll
Not
see
yet,
that.
not yet.
Yeah, I would look at those because that'll give you an idea of like the level of expectation in terms of difficulty. Usually, the last problem takes the most time, and then the other 2 are usually more quick in terms of what the expectation is. Yeah, I try to make it so it's not too overwhelming.
Yeah, probably like one of the questions might be the ones where you find like the position of all the things and find like where the total weight and total coordinate should be.
Yeah, possibly.
Those ones I see are like that's been like the easiest problem so far that I've come across in statics, in my opinion.
Yeah, well,
Those
you
ones were
should.
fun. Those homework ones, I was like, yeah, this takes not too long.
That's good. But yeah, you should find. I mean, you'll probably see a pattern to the way I do the exams. I try to keep them somewhat not completely predictable, but I don't want to trick you guys. So I try to make them so that I'm really just looking for your level of understanding at a. I want to make sure you guys all have a reasonable understanding of the material so that when you go on to future classes, you're not going to struggle. That's the main purpose of it, not to try to find some obscure problem that requires some special trick to solve.
Yeah.
So.
Okay.
All right.
I might come back tomorrow for office hours with more
that's
questions,
fine.
but so far I think I'm good. I'm going to study more. But yeah, thank you.
Yeah, no problem. All right, Long. We'll talk soon.
Yep. Bye.
Bye-bye.